We are going over problems 4 and 5 from the regression equations. I did a video already on problems 1, 2, and 3. And now we're going to take a look at problem number 4. I'm going to enter my data, go to stats, edit a list, go up to L2 and clear and come back down. I want to clear my list. All right. Now that my data is entered, I would like to go to Zoom 9 for Zoom stat. And I can see I need to clear a line out that's in there. I'm going to go to y equals and go to stats, calculates, number 4, a linear regression. All right, you ready to store your equation? Or you got it memorized?
No, I do not. Okay,
fine. So I go all the way down, enter, enter, enter to store regression equation. Have the calculator do that for you. Okay, so we want to store that equation. Where do we want to store it? We want to store it in y equals. I'm looking for the y variable. I'm looking for the y variable on this calculator. So I go to vars, which means variable, variables, and then at the top it says y variable. That's the one I'm looking for, so I arrow over to y variable. And then it says function. Yeah, that's all we're seeing right now. We won't see the other two until later on. So it's a function. You've been on functions your entire life. Enter. And there are all the different y's that are in y equals. I can store as many equations as I want in any of those different ones. But I'm going to put it on y1. It's already highlighted, so I just hit enter. Now it says store regression equation where? At y1. And then enter, calculate. I'm still going to need my A's, B's, and R's. I know I didn't ask you any questions on this about R, but I will be asking you about that. So you write your equation down. Oh, that's 220. Yep. Is that what you had, right?
Yeah.
Now, if I go over to y equals, look, that equation is stored in there for me. 4.85, blah, 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 blah. It has the exact decimal. So there's no more manually punching in abbreviated line. It's the line. All right. And there you go. You have that. Now you actually have to answer the question. Now that I have my line graph, I can use my calculator to find the answer to the problem. I could go to the table of values. Exactly. And so the table of values, if I look at my table of values that's in blue, where's my table of values starting? Where's yours starting? Well, you're lucky because mine's not anywhere as close. So I can go to table set. And I can set my tables. In blue, it's above window. I can go to table set, and I can tell my calculator where to start. If it's 100 I'm looking for, then I'm going to set it for 98. And then what do I want my table to go by? I can have it go by decimals. Like if I looked at the problem over here and they had decimals in the problem, I could make my table go by decimals. I could put in that I want to go by 0.1, which would be by tenths. I could put 0.01, and that would make it by the hundredths. And now my table's starting at 98. And then I can see 100 right there. Boom, 264.7. Look at their answers. What kind of answers did they give for chirping rates? Did they give decimal answers? So I would give a whole number as well for my final answer. What would be your whole number that you'd give? 265 chirps per minute would be a final complete answer. So with years, you do have to start at 0. So I actually write it right next to my chart. Did you store your equation and all that? Going on stats, calculate. Now I see you're there. You're on store regression equation. All right, so I want to store my equation, regression equation. I go to variable, the y variable, it's a function, and I want to put it in y1. 2.81. Well, you'll know when you go to y equals, or if you go to your graph. And I forgot to zoom in on my stats, so I see my lines there, but not my stats. Zoom number 9. But now that you have your data in there, you can actually predict what they want us to predict. Find a regression equation that uses the equation. Predict the sales in 2015. 2015, you need to figure out, what am I looking for then? With X is what? Technically 6. So like, you mean you're going to look in the table of values at 6? Would that represent the year 2015? It would. It says that 5 is 2008. 6 would be 2009, right? So what number do you think X is? Yes. So we're looking at the table. It was 12, and I believe my table is set for up near 100. So I go to table sets, and let's just start it at 0. Do they have decimals in this problem? They do have decimals in their answer.
We're starting it at 0.
Yeah, we'll start at 0 and see what happens on the table. 0. Yeah, there we go. And we're looking for 12. I mean, you could have started closer if you wanted to, but I didn't think 12 was that far away. And check their answer. How many decimal places? 63.2 million. In 2015, there were 63.2 million in sales. So we did perform linear regressions, and then after that page, we did not finish. We did example 1 with correlation and causation, but we didn't do example 2. Let's enter this data then. Years is my X, and CD singles would be my Y. What am I using for X values? Am I using dates? No. What do I use? I start with 0. What's the next one going to be? It's got to be 2. Because look, 93, 95. 94 is actually 1, but that was the biggest thing right there, was that 95 was going to be 2, 96 is 3, and 97. That's why I like this one, because it doesn't go in order. Stats, calculate. Number 4, linear regression. List 1, list 2, and now I'm going to store my equation. Variable. Looking for the y variable, the function, and there's y1. I'm going to store it in y1. Before I leave this page, write down my equation. Find the equation. That would be y equals 14.45x plus 2.43. Go to my graph, see that my line is there. And then I need to figure out 1994. Okay. Now that we have our best fit line, we can predict 1994. So how do I do that? What am I looking for? When it says 1994, what am I specifically looking for? What represents 1994? I'm looking for when x equals 1. So you can go to your table of values, right? Look for 1. I know that 1 was within my window range, so I'm going to use the calculate button up here. It means calculating other things, a value number 1. And I want to know when x equals 1. And I got 16.89, right? So we have 16.89 what? CD singles shipped. But you really can't have 16.89 CDs, can you? So I wonder what a better answer would be for this. 17? So you focus in the center where the variable is. Wherever the variable is, that's where you're going to zoom in on, because you're trying to undo any operations. And it does have a fraction, so technically I can think about clearing fractions, but what I'm just doing here is undoing the division. What's the opposite of dividing by 3? Multiplying by 3. So I'm going to multiply every single thing in here by 3. That means the first term, the term in the middle, and the term on the end. All 3 of them need to be multiplied by 3. That's how you clear fractions. If there was another fraction there, I would just find the common denominator and multiply by the common denominator. All right, for the first one, nothing cancels. It's just 3 times 4 is 12. On the second one, 3, if I make 3 a fraction, 3's in the numerator, and there's a being multiplied to a 3 in the denominator. What happens to the 2 of them? They cancel, which is why we do that. And we're left with just 2y minus 5 is greater than or equal to 3 times negative 2 is negative 6. And then you're just at a two-step equation, complex inequality. What do I undo first? Multiplying or subtraction? So I add 5. How many times am I going to add 5? So how many times am I going to add 5? A total of 3 times. I'm going to add 5. We have 2y left. 12 plus 5 is 17. Negative 6 and positive 5 is negative 1. And how many times am I going to divide by 2? 3 times. Divide by 2. And I didn't multiply or divide by any negatives, so I don't have to worry about flipping my inequality sign. 17 halves is how you leave it. It's reduced. There's no common factors to pull out of 17 and 2. 17's prime, so you leave it. And then we have negative 1 half. Done. And then number 52 will be a good one to show about clearing fractions. So this time we have 2 fractions, and I need to think of a number for what is the least common multiple or least common denominator for 6 and 8. 24 works for both of them, so that's what I'm going to multiply by then. The entire equation is being multiplied by 24. Once to this term. So the first fraction gets multiplied, the second fraction gets multiplied. What else is in there? The 2, well, they're not grouped together, right? They don't have parentheses around them. So both of them are going to be multiplied by 24 as well. They're not in parentheses keeping them together. They're actually separate terms. They're not in a division bar trying to keep them together. A fraction is one term. Even though it has a lot of stuff in it, it's still considered one term. All right, so what's going to happen on the first time that I do it? You have 24 times 3 minus 4y over 6 minus 24 times 2y minus 3 over 8. We're distributing the 24. 24 times 2 minus 24 times y. I distributed that 24 onto all the terms. So you're looking at 24 to be a fraction. 24 in the numerator and 6 in the denominator. What happens to 24 and 6? 6 divided by 6 is 1. 24 divided by 6 is 4. So you have 1s for both of them in the denominator, which means you don't have a denominator anymore. It'd be 4 that we have in the numerator times 3 minus 4y. Once you get used to doing this, you will actually go right to this step. You won't even write this step. You're going to be like, okay, 24 divided by 6 is 4 times the numerator. The next one says minus, well, what's 24 divided by 8? 3 times the numerator. You have to multiply by whatever's left in the numerator. Or you can see the cross canceling here, 1 and 3, and then double 24, and then negative 24 times y is just negative 24y. And now you're left with no fractions. Always. And so it just says to draw a number line. Draw a number line and graph the solution set. So I just like to have symmetry. I could say this was negative 27 halves. This is positive. Pretty open to how you guys want to do it. What kind of circle do I put at 27 halves? Open or closed? Closed circle. And then it says that y is greater than 27 halves. Greater than, whoops, you're welcome. Greater than is always going to the positive direction. So that means I could pick any number greater than 27 halves and substitute it in. And if I get a true statement, then I've done it correctly. we could take our answer. It's 27 halves. So you got to keep it in parentheses to keep it grouped together. 27 halves. I'm going to store that answer in the variable. Here's my store button here, store. It says, okay, well, where do you want to store it? I want to store it in the variable button. And then I hit enter, and it says, okay, x is going to be 13.5 now. All right. So once you have it stored, then you can go ahead and punch in the left-hand side of the equation. You got to keep parentheses around this to keep it grouped together. You actually need to keep that. This is a complicated problem to do it on. So I do have two different sets of parentheses here. I'm going to use the blue one above parentheses, a squiggly bracket, to keep the fraction grouped together. Squiggly bracket, and now I want to keep my numerator grouped together, so I'll use the rounded one. 3 minus 4x, using x because that's the variable we have in our calculator. Close the parenthesis, and then we're going to do divide 6. And then I'm going to close that fraction altogether. So I have squiggly brackets on the outside as well. Squiggly brackets to keep this fraction together. Regular parentheses to keep the numerator grouped together. And then you're going to punch in the next one. Minus, open a squiggly bracket to keep your whole fraction together. And then open a parenthesis to keep the numerator together. 2x minus 3. Close your numerator bracket, and then divide 8, and close the fraction bracket. And then we hit enter. And it says negative 11.5. So on my paper, I am just going to put my check. And the left-hand side was negative 11.5. The symbol says greater than or equal to. Well, when I punch in my next one, whatever I get for an answer, it better be greater than or equal to negative 11.5, or I didn't do my work correctly. So here you're doing a check, but you're not doing an algebra check. Okay, you're doing, did I do the problem correct? You've already been in algebra.
Yeah, we don't
okay?
know.
Okay, so we're going to do the same thing, but this time we're doing it for 2 minus x. So we just go 2 minus x. That one's easy enough. And hit enter. And it says negative 11.5. So we got the equal part of it then. Negative 11.5. Check. It's on a line. Okay. So you do have graphing calculators. You could have moved everything to one side and just graphed it to see if it was linear. But there's something else that, like, give me, what have we been using for a linear function? What equation have we been using this whole time? Y equals mx plus b. And what are the two variables that are always going to be in every single equation? Exactly, y equals x. It's about the x. What degree is the x? What is the exponent? What's the degree? It's degree 1. All lines have to be a degree 1 or it's not a line. So when I look at number 8, what's the degree of problem 8? What's the highest degree, you say? 2, that's a degree 2. Is that a linear function? No. It's a degree 1, x, degree 1. So yes, if it has just an x in it, that's fine.
So is that all you do for this? Like,
yeah. No, you're just determining whether or not they're linear functions. This whole section is pretty much about linear functions, so they're just trying to make sure that you know what a linear function is. What about number 10? You think 10 is a linear function? Is that? Is there something in the problem that throws you off that you're like, Number 10? Ainsley, is there something in the problem that you're kind of questioning yourself? This one right here, right? So is this a degree 1 problem? The question is, what's the exponent on this one? 1 over x. It has an x to the 1, but it's in the denominator. Do you remember how to switch between numerator and denominator with variables? You change the sign of the exponent. It's x to the 1 in the denominator. That means that it would be x to the negative 1 in the numerator. So is 1 over x going to be a linear function if I know that it has an x to the negative 1 exponent? So, nope. It can only be just x to the positive 1. What about number 9? What's the exponent for a square root? The square root of x. How do I change radicands into an exponent? So there's the 1 with the x, and then the 2 is out here. So that would be x to the 1/2. You take the 2 and put it underneath the exponent. So that would not be a linear function either.